This is in October, November 2022, variant 42 question. Number 4. Figure 4.1 shows the variation with time t of the height h above the ground of an object of mass 36 kg that is undergoing vertical simple harmonic motion. So this is figure 4.6, figure 4.1, sorry. And from the graph here, we can get the period, which is 4 seconds, and the amplitude, which is 8 centimeter. The motion of the mass of 36 kg is shown in this diagram. This is the motion of the object of mass 36 kg. A shows the position of the equilibrium position of the mass, and the mass center of the mass is 10 centimeter from the ground. At B, the center of the mass is 2 centimeter from the ground. At C, the center of the mass is 18 centimeter from the ground. At A, the object is either moving fastest upward or downward, depending on whether the mass is oscillating upward or downward. And then at B, the mass is at rest and the mass is about to move up. Then at C, the mass is at the maximum height. The mass is at rest and the mass is about to move down at C. Therefore, figure 4.1 is a graph of displacement against time. And then from the graph, you can get amplitude, which is represented by this point here, which is 8 centimeter, and the period, which is 4 seconds. Then for part A, for the oscillation of the object, we have to determine the amplitude XO in centimeter. And we know that we can get the amplitude and the period from a displacement time graph. So the amplitude is 8 centimeter, as you can see from here. This is amplitude. And then we have to show that the angular, part 2, we have to show that the angular frequency is 1.6 radian per second. We know that the period is 4 seconds. Therefore, we can find the angular velocity, which is given by 2 pi over t. So substituting the period of 4 seconds into the equation will give you 1.6 radian per second, to 2 significant figures. In part 3, you have to determine the total energy E. The total energy is the sum of the kinetic energy and the potential energy during the vibration. Your E is also equals to the maximum potential energy or the maximum kinetic energy. So therefore, your E is equals to the maximum kinetic energy, which is half m, the velocity max square, where V max equals to XO. XO is amplitude, and then times omega. Therefore, your E equals to half m XO square omega square. Substituting the values of m, x amplitude, and the omega into the equation will give you 0.29 joule. In part B, we have to sketch the variation with height of the kinetic energy AK of the object. The graph is given here. This is the graph. The maximum kinetic energy is 0.29 joule as calculated in the question. Then we know that at 2 centimeter away from the ground, when the center of the mass is 2 centimeter away from the ground, in B, the object is stationary here. Then at the equilibrium position, which is here, the equilibrium position, the object is either moving faster, either up or down. In other words, the object is moving most rapidly here at the equilibrium position. Then when the center of the mass is 18 centimeter from the ground, the kinetic energy is 0 because the object is at rest at this point, at the extreme points. This is a summary of the facts that you need to know to solve this question. Number one, you must be able to analyze, interpret the graphical representation of displacement time graph for simple harmonic motion. Number two, understand that you can obtain amplitude and the period directly from the displacement time graph. Number three, from the period of the vibration, you can then calculate the frequency using the formula frequency equals 1 over period t and the angular velocity, where angular velocity equals to either 2 pi f or 2 pi over t of the vibration. We can then combine, number four, we can then combine the amplitude xo and the angular velocity omega to calculate the maximum velocity and the maximum acceleration. The formula for maximum velocity is equals to omega times xo, and the formula for maximum acceleration is equals to omega squared times xo. Number five, understand that simple harmonic motion is possible because of the interchange between kinetic and potential energy. And you must be able to draw the energy displacement graph for simple harmonic motion. Number six, recall and use the energy equals to half m omega square xo square for the total energy of a system undergoing simple harmonic motion.